when you think about the practice of doing statistics, what are some of the key practices or, if you will, habits of mind that you think about while you're engaged in doing statistics? And how can we help our students and our teachers kind of engage in that in classrooms?
Why don't I start? Because I just have one I rely on.
Okay, good. A rule of thumb.
I was doing a session at the National Council of Teachers of Mathematics annual meeting one year on some statistics work with teachers. And in the audience was Dick Schaefer, who is a statistician in education and stats. And at the end of it, one of the teachers raised her hand and said, well, I have to tell my students, I help my students know when they choose to use the median or when they choose to use the mean for a set of data. And that actually wasn't what my session had been about in terms of rules for this kind of thing. And so I thought, well, Dick Schaefer's here. I said to Dick, do you want to try to field that one? And he stood up and he said, it all depends. And that's exactly what you have to have with statistics that doesn't happen in mathematics. It all depends on your question. It all depends on your data. It all depends on what you're trying to say. So any choice is made. I knew what she wanted to know. I can tell you what the rules are in terms of picking the median versus the mean based on the data set and how it's skewed, but that isn't what he said. He said it all depends on what the purpose of your investigation is, what your data is, what's going on. Right. So when people ask me about that, I say it all depends. That's what statistics is all about.
Yeah. I like to kind of think about that as embracing uncertainty. And being comfortable with that.
Right, and I love to say, well, it all depends.
Yeah. Webster, do you want to add to that?
Yeah, so I look at lots and lots of data sets each week. Just in the analysis phase, which I think I don't like focusing purely on that, but just when you get a set of data, too often people start trying to produce graphs and things of that nature immediately. That's a very bad habit because you first of all have to consider the context of the data. You have to validate the data relative to that context. Does this data make sense? You really have to think very carefully about the data and its appropriateness. Is it appropriate for certain types of analyses before you do anything else? And then once you pass that data validation stage and you understand your data and the values that you have in some reasonable way, and you want to take it a step further and summarize it, then you have to think very carefully about what parts of the data do you want to use. Oftentimes you do want to filter the data and look at certain cases. In terms of understanding variation in data, the ability to filter and group the data in reasonable ways is something that is very, very important. Those are things that I use daily whenever I look at data sets.
Yeah, I think so. Chris?
So I'm gonna put a plug in for a forthcoming document. Hopefully it will be available in April for the National Conference for Teachers of Mathematics conference, annual conference. I've had the good fortune of chairing a writing team for a new document commissioned by the American Statistical Association called the Statistical Education of Teachers. And this is a companion document for the book, The Mathematical Education of Teachers, #2. And one of the things that was developed with the Common Core standards here in the United States was something that we call the mathematical practices. And this is basically certain practices, oftentimes they're called the process standards. It's sort of our habits of mind, how we deliver the curriculum. And one of the things that we did in this document is we took the mathematical practices, there are 7 of them, and we actually put them through a statistical lens. So we wrote descriptions of the mathematical practices through a statistical lens. I thought I might just mention 2 of them.
Yeah.
The first one is making sense of problems and persevere in solving them. And I think Webster actually has just rewritten what we wrote. What Webster...
Great minds think alike, right?
Great minds think alike. Basically, what Webster just said about his habits of mind and how he thinks about working with statistics is exactly what we tried to describe with that first mathematical practice. In terms of, once you have your research question that you're then trying to follow up on, you must constantly persevere. And you must constantly reevaluate each of those 4 steps. And you also have to realize that they're interrelated. It's like you just don't finish with one and move to the next one.
Yeah.
The other one that I thought I would mention is the practice called attend to precision. And I think that as far as a mathematician is concerned, the first thing that you think about with attend to precision is computational precision. But in statistics, it's really more than computational precision. And I think the best way that I can summarize this long paragraph that we wrote is, we wrote the statement, in statistics, you are precise about ambiguity and variability.
Yeah. Yeah. So it's not just that you have to embrace that.
You have to embrace it.
You have to embrace that when you describe something as a typical value is this.
That's
you have to
right.
embrace that. That doesn't mean that that will always
That's
happen.
right.
That you need to expect that variability around that number.
That's correct.
Yeah. Yeah.